everyone, welcome to the first video in a series of Rust for C++ developers, where we're gonna go over the Rust language as quickly as possible, and we're gonna assume that you know intermediate or advanced C++. So this basically, you want to do quick and dirty Rust, you need to write some code in production as quickly as possible. This is the series for you. All right, let's go ahead. All right, the first thing, we're gonna look at the advanced hello world. Here we have function main, right? Every function in Rust starts with fn keyword. You don't have to return type for the main. Usually a return type goes on the right side. In the main is not required, right? So you can just type function main and happy days. All right, so now let's look at how to create variables in Rust. The first thing you want to do is say let and then the variable name, right? What this does, it actually creates an immutable variable, which is actually opposite of C++, right? Where you have to say constant. You actually have to do the opposite in Rust, where if you want to have a mutable variable, you have to say mute, right? So then, over here we assign the string slice, and then we print it. In order to print it to steady out in Rust, you have to say println macro. And macros in Rust are a little bit different than C and C++. So like a lot of people use it, so it's not as looked down as in C or C++. There's still some limitations there, so don't just go crazy on it. Okay, so this is the second example, right? We have mutable message, right? We can actually modify it by doing push string and then output it. Lastly, we look at the if statement, right? So the if statement in general the same as what you see in C++, except that you don't have to write the parentheses. You still need the brackets, but no need for parentheses. If you do write the parentheses, compiler will basically just warn you and it'll be fine. All right. Next, let's look at the match. This is actually very similar to switch statement in C++. The compiler also applies similar optimizations where you would use a jump table, right? And if it's a constant, you would use an array. So let's look at the structure of a match. Basically, again, also Rust is actually it's an expression language, right? So you can assign the value of anything to some variable, right? Whether it's a match or if statement. So for example, in C or C++, you cannot assign the result of a switch to a variable, right? In Rust, you can do that. So for example, over here, we do match and we match on a number, and then we return, if it matches 0, we return 0. It matches 1, we can do something more complicated, right? Where we have these brackets. We do something here, and then at the end, this is one thing that people get surprised about Rust is that the last expression, you actually don't have to write the return format. You can just leave the last expression as is without the closing semicolon, and the Rust will evaluate it as a return value of the block. So in this case, you see we are missing return and we are missing the semicolon. If you put the semicolon there, then nothing will be returned, and the compiler will warn you saying, hey, there's no value returned from this block. And so the compiler in Rust will actually ensure that you match on every possible value. So you have to and integers, of course, you have to just go crazy, right? So what you can do, you can put a default value, like imagine default and switch, where you can actually put this underscore, basically says ignore the value and match to everything else, right? It says other here. The other good thing about match is that you don't have to actually have a break statements. Once it matches, right? All right, then we just output here and happy days. Let's go to next. All right. In this case, this slide is very similar to the previous one, except where we are showing the types that are being used, because the Rust, what it does, actually deduces the type. You don't have to specify it directly. So imagine as auto in C++, right? It's actually a bit more powerful in Rust than auto. But basically, if you do want to force the type, in certain cases, you do have to force the type, so you can do something like this. One interesting thing you can see here is the string slice, right? There are two types in Rust that relates to strings, right? There is a string slice and there is actual string class. So let's quickly look at it. The string is basically very similar to std string, where it owns the data that it operates on. You can allocate the buffer and everything like that. You can extend the string, right? It's modifiable. And then the string slice is very similar to constructor in C++, where it's immutable. It just points to some slice of memory somewhere. So just think of it like this. Most of the time you're probably going to use string slices. There's like basic, it's not as hard to work with those as in C++, where you have to constantly do C string and all that stuff. It's a bit easier in Rust though. All right, next, let's look at this notion of a shadowing. So in Rust, you remember we mentioned that every variable is immutable by default, right? But it has this quirks where you can actually say let message equal to something, right? And then you can right away say let message equal to something else, right? And it could be even different type. So you wouldn't think it's a big problem. The only problem where it shows up is in the shadowing, where let's say you have a message equal to hello string, then you have a new block, right, where you say message equal to something else. But once you get out of the block, you get original message. So it's more like a stack, right? So you just have to be very careful when you have a huge amount of like lines of code, right? You have to make sure that you don't mess it up. All right, next. In this case, we're just going to show you the conditioning, right? Similar to like ternary operator in C or C++, right? Basically in Rust you can do stuff like this, right? Like if condition number is equal to this, else number is equal to 24. The cool part actually about this slide is actually is that say you have this notion that, because you know we have this in Rust this requirement that the number is immutable, right? By default. So like you see over here it doesn't say let mute number, right? Usually what you would do coming from languages like C or C++, you would say, okay, let mute number and then initialize it later, right? Depending on condition. Let's say on this point, you don't know what to initialize it for. Rust actually allows you to say let number and then initialize it later, and still this number will be immutable, right? This variable will be immutable. It doesn't have to be number, it could be just any variable. So I think it's actually very cool. There are reasons why it's allowed. And one thing to notice that, let's say if you decide to use this number without being initialized, the compiler will actually prevent that. They'll say, hey, the variable is not initialized, you're not allowed to use it. Okay, then this is, it's most like, you can see where we can initialize the number the same way like we did previously, but we can do it right away, right? If condition, like similar to basically how ternary operator work. The Rust itself doesn't actually provide ternary operator as a separate functionality, because everything in Rust is expression, right? So there's no need to have a ternary operator. You can have an if statement or match or whatever you want, right? Similar way here. Okay, I'm gonna show you some enums, right? Over here, actually, we showed this cool power of match and enum. You can see that we can actually, let's say we have this simple enum, right, with 3 values, and then assign it to this variable. Then we can actually extract with the if let statement. And we can extract this enum, right? If it's equal to that. It could be, if it's another variant, for example, instead of some variant, you would go into this else part where it says not a sum variant. But if it is some variant, you will actually assign this value to 42, right? It will extract it. Some call it destructuring. And then you can use this value. So what it would print here would say found value 42. All right, the next one is inner functions. Basically, you can create the inner function inside of other function. So in this case, we have this outer function, and inside we create the inner function and call it, right? Similar to what you've seen in like stuff like Python, right? In this case, inner function actually visible in the whole outer function. Just remember that. And one thing, that inner function actually have no way to access anything inside of outer function. So if you have a variable here, inner function cannot access it. All right. Loops. There are 4 types of loops, right? While condition block, something that you've seen in C++. Then you can say while let pattern equal to expression, right? So expression gets evaluated, assigns to pattern variable. Then inside of the block, you can use the pattern. Then there's a loop, just loop like this. It's basically infinite loop. The only way you can get out of it with the breaks. And then for pattern and iterable, which is what you've seen in modern C++ or Java, right? All right. So let's just look at this very common loop. When you say for I in 0 to 5, right, you just go from 0, 1, 2, 3, 4, 5. And basically this dot evaluates to this range, right, 0 to 5. If you're familiar with ranges in C++, that should be obvious. Okay, this is another example of loop. You see this like infinite loop right here, and we can actually break from it. And again, you remember I told you that everything in Rust is expression, so we can assign it to any variables. You can see over here we return the line, and if it's not returned nothing, it assigns to answer. Answer gets printed. Happy days. Everybody's happy. One thing to note over here, you see that we do lines with this squiggly line, right? ampersand operator, right? So basically what it does actually as a reference, because otherwise if you just do for line in lines, over here what will happen, the move will happen. Apple will be moved to line, right? Banana will be moved to line. And then after that, the lines would actually have undefined stuff in there. In the future lectures, we're going to talk about moves and stuff, how they work. They work very similar to what you see in C++, or like C++ unique pointers, right? But there are some tricks there. In the next series, we'll talk about that. All right, the last thing I want to show you, this like really weird thing in Rust that you can technically do in C++, but it's like really bad. So they have this thing called lifetime labels. But in this case, they used in a way where it's almost like a goto, right? Like you can actually break from the inner loop by going to break and specifying the lifetime outer, right? So then you go to actually outside loop. You break not from inside loop, but you go all the way to the outside loop break. I think that's it. I hope you guys liked the video. Please like and subscribe. Let me know if this stamp is good.